待たせいたしました。これよりメイツトラックではコンピューターサイエンティスト、ウェブエンジニアのトルステン・ザイシャブ様によるセッション、Vue で 3D を楽しむをお届けします。Vue Fes Japan 2025では4つのトラックを同時進行しています。このメイツトラックについては画面右下の方にありますハッシュタグ Vue Fes _ メイツでどんどん感想を共有してください。トルステン様、よろしくお願いします。
Hello and welcome to my talk. Thank you for the warm introduction here at Vue Fes Japan 2025. My name is Thorsten Seyschab, as I was already warm welcomed here, and I'm talking about you playing with Vue in 3D today. At the top right corner, you see a little QR code. You can scan it, and over the course of the full talk here, you can send little emojis to the screen, and you also have the possibility to take with me a little live polls and quizzes that are during my talk on the slide. So if there is a live question and a live quiz, you can see it on the top right corner. You will be notified on your phones. The question will hopefully pop up there automatically. As it is a bug-driven development, I hope everything will work today. And if you have found any bugs in the software, please raise it on GitHub. The whole software is open source and it's completely built with Nuxt. So you are free to use it as well as in your own talks maybe, or in other projects of your choice. So I myself, I'm an IT consultant and web engineer. I'm currently working self-employed as a full stack developer. And in my everyday life, I am using Nuxt, Vue, and also other meta frameworks and other lovely frameworks out there as well for my clients. So let's see what we will learn and see in this talk. So like you can see here, this is what a live poll will look like, and I hope it will already work. First answers come in there, very nice, very live. So in this talk, we will go over why we should use 3D on the web. So this is a little bit of the motivation, introduction at the beginning. After that, we will understand what a 3D scene is capable of, how it is structured, what tooling we need for 3D scenes, how the pipeline is, and how we can build really very simple 3D scenes in only a few steps in the browser, maybe today after this talk in like 5 minutes. After that, I will showcase you a real life problem with a proof of concept we made in a friends group of mine, because we built a little browser game that is completely run in Vue. I will showcase it to you. We will take a look into it, and then we will identify a problem in our proof of concept, and we then will make a solution for it. And this is the last thing, that we will extend it with a more build tool agnostic plugin in order to see how we can enhance the open source community. So let's see how you guys voted here. The question was who has already used 3D on the web before, so that I know my audience here. And most of you guys never used 3D at all. But of course, that is not really 100% informative here, because we have 3 times a yes and only 1 time a no. Combined, of course, you have used it either as a user or as a developer. But most of the people are using it, but not really developing it. And we will change that today, because I will show you how nice, awesome, and easy this is. So why should we use 3D on the web? Of course, there are many possibilities where you can use it. You can build e-commerce web shops that enhance like 3D models. Let's say your customer wants to sell a product like a shoe or a fridge or really anything, maybe a car. And you can plug in some 3D into it so that the clients of your client can customize the car in real life, rotate it, change the gear, the color, or like Nike has done it in the past. You have your shoe and you can customize it directly in the browser, rotating it and seeing that it comes to life. And the question, why should we use the web for this, is rather simple. It is accessible anywhere, you have not to download and install something, and it works across all devices. Hopefully on all browsers. Of course, there are differences between Firefox, Chrome, Safari, and so on, but most of the time, the developer of the big dependencies try to get it working on everything. So, okay, now we know why we should use 3D on the web. Now let's try to understand a scene in Vue. So on the left side of the screen, you can now see the steps that I am presenting to you, that you can create a scene. And on the right, you see the live result as really the demonstration of this. So the first thing we need is a renderer. In parallel, we have a little live poll again. I will come to this in just a second. But the renderer has on the really bottom the GPU. Of course, the GPU is rendering your image for your screen at the end of the day. On top of the GPU, you have WebGL. WebGL is a really low-level API in the browser. It can directly communicate with the GPU. That is why WebGL is on top of the GPU with direct contact, but it is rather complex. So you trust me on this, you really do not want to code in WebGL. It is frustrating, it is bulky, you can do it, but you should not do it. On top of WebGL, there's ThreeJS. I think most of you already heard of ThreeJS at some point, and ThreeJS is a high-level framework on top of WebGL. It simplifies the workflow with WebGL, so you can use ThreeJS in a more easy way to write WebGL code. And before we go to the last step, I will just take a look into the live poll. This year was the question, which framework can we use as Vue and Nuxt developers to get 3D scenes inside of our applications? And I made up 3 of these. So the Vue 3D2GL, the JS Vue and the Babylon Vue are not existing, they are just made up. The answer here would be TresJS is what we can use, and rather the half of you guys already heard about this, because TresJS is on top of ThreeJS for the Vue and Nuxt environment. So we can use this to really get to understand ThreeJS. So TresJS is a wrapper around ThreeJS, ThreeJS is a wrapper around WebGL, and WebGL is communicating with the GPU. And if you're not in the Vue or Nuxt ecosystem, for example, if you're in Svelte, you can use Threlte, or if you are used to program in React, you have Drei, and there are many others. Just to call a few of them, they are sitting on top of ThreeJS. So until now, we just know what the renderer will look like, but our screen on the right side is still empty. So let's see how we can use, of course, our programming language to get some 3D scenes up and running. And in ThreeJS, we have 2 ways of doing this. We have the declarative way and we have the imperative way of declaring our 3D scenes. The declarative way is what we are most used to in Vue and Nuxt, because we can write real DOM elements inside our template tag. So here you can see we have our template, and inside the template we can create a Tres canvas, and inside the Tres canvas we can add light. Here it is a directional light. I will come to that in just a second, bear with me here. The same code in the declarative approach can also be coded in an imperative way. The imperative way is the real ThreeJS way. So inside our script tag, because ThreeJS is a JavaScript library, we can create the light, set the position to a light, create a shadow map, and then add it to our scene. And because the imperative way is ThreeJS, we can use imperative inside Three and Tres. But because of Tres wraps ThreeJS, it can enhance it with this DOM-like template approach, as you can see it on the declarative approach at the top of the screen. So now we have the renderer. The next thing we need is a canvas to show something. Our screen is still blank here. So let's create a canvas with just, I'm using now TresJS further on in these examples. We can create a Tres canvas, throw it in here, and Tres is already creating everything in the background for us. Nothing more for us to do than maybe set a clear color, that is a background color. Here it's a light blue, maybe the background of a game, the sky, for example. So that is something now we can really see in our browser. So the next thing after the canvas is we need a world. Here I created a little grid helper and an X helper so that we can see something in our scene. After we have now declared a world, we also need a camera. The camera always has a starting point at the tip. Then it spans a little red part where the screen will be rendered. And then we have a clipping plane, so a far clipping plane. That is the plane that is far away. And a plane called the near clipping plane. That is the one that is on the camera lens itself. And everything in between the near and the far clipping plane is rendered on the screen. Everything that is nearer or far away will not be rendered on your screen. And of course, I tricked you a little bit, because this on the right here is a real interactive 3D scene already. And in order to see something, we need a camera. So we are here one camera, and I printed a second camera to show you guys how a camera can look like. But actually, this scene has two cameras, just to be on the right track here. So after now we have a camera, we can create a light. So now it gets a little bit full here, so let's deactivate the camera. So now we have only the light. You will see that the light is very similar to a camera, because it also has a near clipping plane and a far clipping plane, and also the source. The source is where the red lines will meet each other. But unlike the camera that only renders what is in between both of them, the light will throw shadows and cast the light only in the box it spans. And it's really a rectangular one here, so that is why it looks similar but not the same like a camera. And it is nearly the same. We just say, hey, let's create a Tres ambient light. It has an intensity, how strong it will be, and it has a color. The ambient light is a light that you have always present everywhere. It is like the default value of light. See it maybe like the sun. And the directional light here, this is what we can see here as the grid. This is more like I have a source, I have a direction, and I can cast with this a shadow, because the shadow of course needs also where does my light come from, because on the other side the shadow will be thrown. So now we have lights in our scenes. The next thing is we can create a mesh, for example a little cube here. And with this cube, I just placed a Tres mesh here. I will create a geometry inside of it that has some positioning, an X, Y, and a Z axis, and I will give it a material. Here it is a default basic debug material. Of course, real object has colors and correct materials, but this one is just a normal basic material. And the plane also has a material. So we have the plane on bottom. This is the first one, and the second one, other way around. The first one is our cube, and the second one here is our plane. Just with these lines of code, you already have a scene. I can rotate it, and I can see a little cube. That's really nice. So after we now added some meshes, we want to show shadows in it. And here's also a little question for you, because the shadow, as you can see here, is not really rendered to the end. It is cut off. Why is it cut off is the question here. So I will just show you the camera again. So this is our camera, this is our light. Maybe you can figure it out on your own if you are professional. I think we are all professionals here at this point. So the answers would be, it could be a bug. It could be because the shadow is only rendered in our camera and the camera clipping is too far away, or because the light doesn't shine far enough. The correct answer here is that the light is not shining far enough. As you can see here, the camera, I can just deactivate the lights here real quick. The camera is rendering correctly. As you can see here, the beam of the far to the near clipping plane is outside of the shadow, so it has to be something with our lights. And if I can see the light, I have the near and the far light planes, and if I extend the light plane, you can see the shadow will come back. And that is the difference between the camera and the light boxes. A light box is responsible for the shadow lengths and for what your light will do, how far the light can shine, because other than in reality, the light will stop at the far plane after the light. It will just end. The light beam has an end. It's not like in real life. The camera, on the other hand, will clip what it can see. That is the difference here. And the thing how we do it is that only we have to do that on the trash mesh. We want to cast a shadow, so that the cube will cast a shadow. And on the trash mesh for the plane, it will receive the shadow. And of course, if we have multiple things, or maybe if you want to cast shadows on itself, like you have, for example, a more complex model, like a human, and I can, with my hand, cast a shadow onto my face somewhere if there's light, then I, of course, have to do the cast shadow and the receive shadow on the same object to cast myself onto a shadow. So that's cool. Now we have shadows. The next thing we need is a model, because a cube is too simple. It's everyone can see a cube. It's the hello world of 3D, of course. But we can, of course, render also models like this little train here. I'm very sorry for this little grayish thing here. This has something to do with Chrome, because I tested it in Firefox and now I'm using Chrome for other reasons. But you have to play around there a little bit with some values to get it right in all browsers. But this is a real-life example on debug before you go into production. But we have a little train that is very nice. It is also casting the shadow correctly. We can also reduce the light shadow to clip it off. So it's just working, and everything we have to do is we have to load a model. And the model is here as a GLTF model, and we just paste in the file into it. This train is called a keyboard. Don't know why, but it's an older example from myself. And we have to use a suspense, of course, because we load a file, an external file. It has to be loaded before we can show it. So that's why we wrap it with a suspense. And GLTF, we will come to that a little bit later, is the default file format that we can ship out 3D models in the web. And the only thing we have to do is tell TresJS here, this is a GLTF model, load it for us, please. And of course, it can cast a shadow and receive a shadow because it throws shadows on itself, like here on top. This is a little shadow thing here where it casts on itself. So we have both values here at the same. And that's cool. So now we have a model. The next thing we can do in the next step is we can have some interaction. Because only having the model loaded and shown is rather boring. Like in my example before, we want that the user can maybe interact with it, change things or something like that. And this is done like in Vue and Nuxt by default with the add-click event, because we are inside Nuxt. Everything is reactive here. We can use our Vue and Nuxt syntax as we like and as we are used to. And the add-click handler is as easy as it is with a function model clicked here. So when I click now on maybe the train, okay, I click this. And of course, here I just print the name of the object. So if I click here on the top, it is the collector of the train. And I click on the window. Okay, I did not aim at the window, but there's some other model that I can click onto it. And with that, you can make click actions. Very easy, very straightforward. Then after interactions, we can also add some post-processing to it. This is also done very easily. You have just an effect composer. And here I have a pixelation effect so that we can just pixelate the end image. And I have a little slider here to show you the value I can control. It is reactive at the end of the day. So this is just a float value that is passed as a reactive real-time value to the post-processing pixelate animation. And with that, I can control the effect. So after post-processing, everything that we can now do is adding some animations. But I know you are all, and we are all, awesome developers. You can imagine going around with the train a little bit here. But animations is also very easy to do. But I will show you the animations in the little proof of concept. So this here is a little idle game. It is fully programmed in Vue. And it is also open source. You can check it out on GitHub. And it's a little island. Let's speed up the time here a little bit, that the sun will come out. And with that, you have a little island, also a little live poll here if you want to participate in the question, what was the most challenging one here? And I can click on a build plate here. It is reactive. I can just say, hey, is something there? And then I can build a building. Yeah, it's a house. It costs something. It will produce gold for me. Entirely in the browser. No installation needed. Everything is easy. We have little shadows here, as you can see, on the waves of the island. And of course, the waves itself also are moving, if you can see that here on the screen. So there's a little shader effects. And also the fog in the distance is cutting off really nice around the island. And if we would have enough money, what we apparently do not have because we have only 80 in-game money, I could have bought the windmill. This is the last one behind the live poll. And on the windmill, the wind turbine is rotating. So if you check it out, try build the wind turbine and the windmill. It's a really nice building. And there you can see also real-life animations. So let's see what you guys think was the biggest challenge in this game. Most of you think that the day-night cycle with the moving sun was intense. And it was intense, to be honest. So I can just show you the light helper and the camera helper here to show you how the sun is done, because the sun actually is just a directional light. And a directional light that is moving across the scene in the motion of a sun. So it's just a light moving around, and it is doing like a sun, but it is no real sun. So this was quite challenging, but not the most challenging one. Also, the water effect was rather okay-ish to do because it's a shader. You can, because we are in WebGL, just use all the shaders you are used to write, or maybe you will learn to write. So it's a plane. The water is just a blue plane, and then there's a shader on top of it that will simulate waves, but there are no actual waves that have no collisions or anything like that. Also, the fog on the horizon, that was also a shader that is rather complex because normal shaders have the camera position, not a real-life world position, but the most challenging one was using model files. And now you think, why is that? Model files are just click and place and then they are there. Yes, but they are not type safe. And that is why I will talk about you in the last 10 minutes about GLTF files, because they are not as easy to use as you might think. GLTF files, like I was mentioned before, is the one thing to load a model into your scene. And GLTF files are JSON encoded files. On the left side, you can see such an example of a GLTF file. And on the right side, you can see the object hierarchy that is built with this GLTF file, what it will describe. And on the first level of the GLTF file, you have all these keys like the scene, the nodes, the materials. And all of these are arrays. Okay, so on the most top level, we have the scene. For example, the train scene we saw earlier. So we have one object inside our array. This is called with the name the train scene, and it has nodes. Nodes is an array out of integers. And these integers are the indices inside the arrays of the other objects like the nodes and the materials. So we do not have any IDs here or any other references. So we cannot really go through this GLTF file fast. We can also not cross-reference it or optimize it, because if we try to change inside the nodes or the materials array the order, then our indices here are not working anymore, because we need the node at position 0 in our array. And also the node at position 42 in our array. These are not IDs, these are just the indices. So going further down, for example, in the nodes, we have only one node because the screen is too small here, but this is node at position index 0, and it is a mesh, and it has a name train. And it then has a scale, translations, and other parameters. And if we go even further down, so we went from the scene to the nodes to the mesh now. Also mesh is just an array. It also has a name. And then all the way down to images and buffers. And these are the only ones that can reference some external files, like an image, for example, for the texture for the plane, or the model itself with an encoded container-like file, because it's a bin file here. Everything else is text encoded, it's a JSON file. So the problem is now, where do we load and use this? And I think you can already imagine going through this GLTF file is more on the runtime side of things. You have no real control on the development time, so no type safety, for example, or other things. The first big problem is that we can really only load it at runtime. We don't see it in development. The next thing is that we do not have typings. We have no code completion. I cannot just simply say my scene name dot train dot window. That is not possible. So no safeguards on build. Maybe I have this island and I myself placed a little rock at the beach and programmed it like get by name rock, and then someone changed the name in Blender, or Blender itself will change the rock to rock001, and then all of a sudden it will not crash on build, but it will not work in production. So that's kind of weird. Also, this get object by name I referenced just a minute ago is just a depth first approach. So this big scene graph, this JSON file is loaded, the object hierarchy is built, and then it's a depth first approach to get there. And if you're very unlucky, you have to go through all of the tree, all the leaves until the very end. This is complex and very bad performance-wise. And also, all of your models have to be in the public folder. You have no version control, no caching, and so on. And all models are always bundled. Maybe I don't use all my trains. I dumped in 5 trains, but my game only supports 1 train at the moment. All the trains are bundled. Also the 4 that I'm not using at the moment. That's bad as well. So we sat down and thought of a solution for this, because we want type safety, we want guards, we want everything I just listed out to be solved at some point. And therefore, we had several approaches. The approach we went with was we want to let ThreeJS load the GLTF file and reflect and persist the object it is generating. The problem here, though, is that ThreeJS is also only in runtime there. It is not possible to use ThreeJS in development time. What is the solution for this? Because we need it, obviously, in development time. Yeah, we can patch it. We can just take ThreeJS. ThreeJS is open source, and yeah, maybe it's an afternoon or something. No, it was like a month or something to get things sorted out in ThreeJS, how it works, how it loads, how we can wrap it with Node at the end of the day, so that we can use ThreeJS inside Node in our development time, so that ThreeJS can generate the object hierarchy, and we can use it and maybe persist it in a cool file that we can use as a generated type-safe guardian file, like a .ds or something like that. So the API design we went for was then we wanted to prioritize the usability. Of course, this is not the best for bundling size, as we have to create really large type-safe files. But for the developer, it is very easy at the end of the day to use it, because now we can do something like island scene.island, and we have full code completion in our IDE, and then it prints out, hey, we have the beach now, and on the beach, there's our rock 001. And if we now change the model and someone renames this rock at the beach to maybe rock 002 or something, then our build will fail. Because we know we expect rock 001, but it's not there anymore in our type safety file. So build will fail and you will be notified not in runtime, but in the development time. So better to have for the developer than for the bundle size. And the bundle size, it is bad, but it's not that bad. I mean, it's just some kilobytes more, which can be quite at the end of the day, but it's our API design we went with. So let's see if our problems are solved now. The first one was it only loads at runtime, nothing in development time. So this is checked. It now loads at build time and we can trigger it in development. That's really cool. Before we had no typings. Now we have typings. Typings are present. We have code completion in our IDE, for example, VS Code or something like that. And we have a safeguarding on the build. So it will fail. Your build will fail if it's not there. Before that, we had a get object by name that was a depth first approach that now is fixed because we have this island scene dot something. Very cool. Also before, our models always had to be public assets. Now they are versioned and models are in the source assets folder. And also only the models we really use are bundled because we can control what models are in the code, and everything that is not inside of our code we can just ignore. And everyone that is using the emojis can see now that I tricked here a little bit the overlay with white backgrounds over the old list points, but yeah, found a nice feature here. So the source code is open on GitHub. You can just check it out. It's a GLTF type toolkit. You can also just extract the ThreeJS part if you want to have ThreeJS in development, or use the whole thing for your next application. It is very helpful because it brings type safety and all the cool other things that are listed here to your project. And the most amazing part of this is that this is build tool agnostic. So this is another talk of mine that I gave some weeks ago, where I was talking about this tool is not only for Nuxt and Vue, you can also use it in all bundlers, Vite, Rollup, Rolldown, Webpack, you name it, this plugin can do it. And we do this by using Un.js, Unplugin, a very, very cool plugin, mainly managed by really awesome people, that allows you to create plugins that are running across multiple instances and very different build tool pipelines you want to support. And that's it at the end of the talk. Here are the sources. You can check out the presentation slides online on GitHub or all the other resources if you want to see this. Also a big shout out to Alvaro, the creator of TresJS. He and his team are making an incredible good job on maintaining this rather complex thing we love to use in Vue and in Nuxt. Also, thanks to Andreas, who helped me with the little idle game and also the GLTF Toolkit plugin, and all to the other nice people that I may have forgotten now. So, thanks for your attention and have a wonderful day today as well.